Minimum. All right, everyone. So then I think that we're ready to get started. So today we're going to have our first in-person seminar in a while, because we have a visitor of Pete that has kindly agreed to give a talk here today. And his name is Alastair Wilson, and he's a professor at the University of Birmingham. And he's going to be talking about naturalism and modality and spatiotemporal things, philosophy of physics of some kind. So please welcome him and enjoy.
Yeah. Hello, everybody. Thank you for bearing with me. Thank you for coming here after. I hear it's been a while since these seminars were happening like this. It's been a while since I was last here. I gave a memorable, to me, talk about 10 years ago here. This is on a different sort of thing. That was very metaphysical. I don't know if anyone here remembers that, but this is more of a kind of philosophy of science, but still a kind of metaphysical approach to philosophy of science. I'm going to start out with some kind of big picture considerations and then move on to something a little bit more specific about space and time in the second half of the talk. So, kind of general plan. I'm going to talk about this program in metaphysics that I, and following others, call naturalistic metaphysics. That's essentially metaphysics that aims to do justice to the content of science. At least that's the way I'm going to be talking about naturalistic metaphysics, making some distinctions between the kinds of naturalism, and then defending a specific epistemic or epistemological kind of naturalism. Next, going to take that sort of naturalism that I've introduced and then apply it to a particular bit of metaphysics, the metaphysics of modality, and say why I think modality is particularly interesting, particularly challenging to give a naturalistic treatment of, but then talk about some different degrees of naturalism you might try to have about modal metaphysics, starting with approaches which are hardly naturalistic at all, and ending up with a kind of fairly radical, even kind of extreme kind of naturalism, which I like. I think very few other people around will like, but there are also some positions in between that you might find more plausible. And then one of the nice things about modality is it kind of factors into metaphysics more generally. So people sometimes have tried to characterize metaphysics as the science of the possible. And I take a different approach to the people that think of metaphysics that way, but I do think that modality, possibility, necessity are very central to metaphysics. And that means if you're, whatever else you're investigating in metaphysics, including space and time, modal considerations are quite pressing. So the kind of middle part of the talk will then play out in the specific case of asking about the limits of possibility for space and time. What could space and time really be like at the kind of outer limits of possibility for them? That's what I'm aiming for. So naturalistic metaphysics, it goes under various names and different people think of it as very different things. But I said it's basically metaphysics that aims to do justice to science, it aims not to ignore science. I guess there's a kind of traditional characterization of metaphysics as an a priori discipline, whereby it's kind of the content of science is in principle irrelevant to metaphysics. Metaphysics you can do from the armchair with your eyes shut without ever going near a lab, without ever talking to any scientists, without ever having done like primary school science. That's, I think, not a very good way to do metaphysics. And so, I'm not alone in this. There's a lot of people that think science does bear in interesting ways on how we should be doing metaphysics. Amanda Bryant, who I'm co-authoring a book on called Modal Naturalism was at the moment, wrote a PhD dissertation on naturalistic metaphysics, what naturalistic metaphysics can or should be, a few years ago. And trying to be all-encompassing, she gives this really very general characterization that naturalized metaphysics is metaphysics that bears some appropriate relation to science. And then you can fill in what that relation is to get particular flavors of naturalized metaphysics. And I think there's two broad sorts of naturalized metaphysics that are worth talking about. One is methodological, that says we should be doing metaphysics using the same sorts of methods with which we do science. Or the way we should be doing metaphysics is kind of, another way of putting that would be just kind of go, if you want to know the answer to a metaphysical question, go and ask the scientist whose work is most relevant to that question and just defer to them on it. Those sorts of approaches are more methodological in nature. And Brian is kind of inclined towards that sort of methodological naturalism. Just brief digression, the term naturalized metaphysics, I think, traces back to Quine, who talked about epistemology naturalized. I think people have some these days often think of this phrase naturalized or naturalistic metaphysics as naturalizing as something you kind of do to a subject matter. So you kind of take metaphysics and naturalize it by pointing like the science ray at it. But that's not what Quine had in mind. Quine was using a kind of sociological metaphor where he, in the kind of sense of the word naturalized, where you might have a naturalized citizen who's somebody that's moved to a country and adopted citizenship in the new country and kind of integrated themselves into that like social political community. And in the same way, Quine's metaphor is that the naturalized epistemologist is someone who doesn't try to do epistemology a priori, but goes and kind of joins the community of scientists, becomes part of that epistemic community, and does metaphysics from the inside of that community. And that's closer to what I kind of have in mind. But that is, again, the more methodological approach. You should kind of do your metaphysics from inside the scientific community, talking to scientists, not kind of from the outside, from another country. So I endorse that. But the kind of naturalized metaphysics I want to focus on is less methodological in character and more epistemological. It's more about the content of science and the use of that content of science as evidence for metaphysical claims. So here's the kind of naturalism or naturalistic metaphysics I'm going to be talking about for most of the talk. It's an epistemological kind of naturalism. And it comes in the ordinary variety and a radical variety. So the ordinary variety just says there is some evidential relevance of the discoveries of science, by which I take to be things that we now know as a result of having done science. And that there is genuine evidential relevance to metaphysical hypotheses. So this is kind of opposed to the view that says, no matter what the scientists might discover, what they might tell us, that's irrelevant to metaphysics, because metaphysics is purely a priori. This basic epistemological naturalism is directly opposed to that. But it's a relatively modest version in that it only says that some of the discoveries of science are relevant to some of the claims of metaphysics. The claims that get made by metaphysicians when they're doing metaphysics, whatever those might be. And of course, there's a radical version that says that relevance kind of runs deeper, it runs throughout metaphysics, so that, at least in principle, any claim that we discover by doing science bears evidentially, perhaps to some very, very small degree, but nonetheless, it does bear evidentially on every single hypothesis in metaphysics. And you might think that's kind of crazy. If you're a Quine-style epistemological holist, where you think that every hypothesis is relevant to every other hypothesis, that kind of just falls straight out. And obviously, I'm going to focus on the main version. Obviously, that comes in degrees depending on how much of science is relevant to how much of metaphysics. It is compatible with there still being kind of some corner of metaphysics that is completely a priori. I'm not inclined to think there is any corner. So I guess I would be kind of inclined to think that all metaphysical hypotheses have at least some scientific discoveries that bear on them evidentially. Having given that version a name, I'll be concentrating on the weakest version to kind of, I think that's still interesting. So just to kind of give a little bit more filling out of the kind of epistemic picture I have in mind here, without going to kind of full-scale epistemological holism, this is a kind of sort of Quinean picture whereby what we're trying to do is come up with a best total theory, or what Quine called a system of the world. And the claim is that any adequate total theory is going to have some components which are metaphysical and some components which are scientific. In terms of like the content of a total theory, we're going to be able to kind of say of some of it that it's metaphysical, of some of it that it's scientific. And the way I'm imagining is that those kind of portions will overlap, perhaps quite extensively. So there will be some claims, for example, claims like about the metaphysics of space and time, of the kind I'll be discussing later, which are both scientific and metaphysical in nature. So it's not meant to be a kind of mutually exclusive distinction here, but it doesn't need to be for it to be an interesting claim that some scientific discoveries are relevant to some metaphysical claims. So how would we go about producing this kind of best total theory, this best system of the world, or I'll call it a package deal? Well, you don't just take your best metaphysics considered in isolation and your best science considered in isolation and kind of sit them side by side. If you're building a package, you want those two things to fit nicely together. You don't want them to be like in tension with one another. And so in principle, when you're building a package deal, you might kind of take your scientific beliefs, your metaphysical beliefs, and where you notice tensions between them, kind of decide what modifications to make so that the total package you end up with is the best possible total package. And so in general, in order to do that, you could modify some of the metaphysical beliefs you start out with, you could modify some of the scientific beliefs you start out with. You'll probably want to do a bit of both. So the kind of logical position is that both of them are open to change, but I do think that there's a kind of asymmetry here nonetheless. The kind of thing in its extreme form would get called scientism. I don't know if I really am a scientist in that sense, but I do think that it's hard to deny that our best theories in science, in physics, chemistry, biology, and psychology even, have a much stronger independent kind of evidential basis of support than our best theories in metaphysics. So, we're in a better position to know stuff about atoms than we are in a position to know things about essences. And though this is kind of extremely rough and ready, I think it's a helpful proxy to just look at how much disagreement there is in any relevant discipline. I mean, you can also look at like how many degrees of accuracy, how many decimal places you can make predictions with. Physics is very good at that. Metaphysics is not very good at that. But you can also look at how much disagreement there is in the relevant community. And if you go and look at like any kind of core metaphysical claim, you go and read the literature or contemporary literature on it, you'll find a huge disagreement about that. There's basically no consensus about anything. Not even logic, not even like simple kind of part-whole composition. And then you go and look at physics, and there's a huge amount of the core theory of physics that is not controversial. Atomic physics is extremely well understood, and we have rationally a very high degree of confidence in the core claims that atomic physicists make. So even though kind of logically speaking, one might expect to be modifying both sides when you're building a package deal, in practice, given this asymmetry in the evidential support, one will expect to be modifying metaphysical beliefs more than scientific beliefs if one puts them together into a package deal in this sort of way. But that's a kind of contingent thing based on our actual state of knowledge of these in these relevant disciplines. So I think that's a kind of interesting version of naturalism that's kind of worth talking about, at least I hope it is. one of the things I like about it is that it isn't an all or nothing thing. It's not a matter of, it's not a completely binary choice whether you're a naturalist or not. You can have approaches to metaphysics which are more or less naturalistic. Basically, in terms of how extensive the parts of metaphysics you think science is relevant or like significantly relevant to. So basically, on some views, science bears a lot more strongly on metaphysics than on other views. And so we can kind of develop some grades, which you could call degrees of naturalistic involvement by kind of, get reference to another phrase of Quine. I'll call them grades of modal naturalism, because I'm going to be focusing on naturalism about the metaphysics of modality in particular. So we're going to move on now from talking about metaphysics in general to talking about the metaphysics of modality, which I think is a particularly interesting case. Yeah. Why modality? Oh, perhaps unsurprisingly, because I work a lot on the metaphysics of modality, I'm inclined to think it's quite central to metaphysics. I'm not alone in that, as I've already said. So quite often, whenever you're doing the metaphysics of something like substance, say, or properties, you can ask modal questions that are deeply relevant to that sort of metaphysics. So if you're doing the metaphysics of substance, you might want to know, well, what are the possible types of substance out there? And how do they differ from the impossible types? Properties, like what are the limits of the possible properties? What kinds of patterns of any given thing are there when you're doing the metaphysics of that thing? And those questions often turn out to be very relevant to the core subject matter. It's reflected in the kind of method of cases that often gets used in metaphysics, where you're trying to say, well, let's try and do some conceiving of cases. We'll imagine some cases. Once we've successfully imagined a case, we'll say, well, that's probably possible then. And once we've got a possible case, we can kind of use that as a piece of evidence, a piece of data in forming our metaphysical view. I don't much like that particular method, but I think nonetheless it highlights the connection between modality and a lot of the rest of metaphysics. It's also a notoriously hard case in metaphysics, understanding modality. There's a paper by Price and Jackson where they talk about the fate of the M worlds, which I think are metaphysics, morality, mathematics, and modality. Sorry, mathematics, morality, and modality, as these kind of particularly hard topics to understand the metaphysics of. And modality has seemed really difficult in general, but particularly resistant to any kind of naturalistic analysis. And so it's kind of particularly pressing to see how strongly naturalistic a view of modality we can give. So here are the grades I'm going to be talking about. Grade 0 is not, as I will think of it, a kind of modal naturalism at all, but grades 1, 2, 3, and 4 are what I would call naturalism about modality, and they're of increasing strength. So the way I'm trying to pitch this is that each grade is kind of strictly more naturalistic, a strictly stronger version of naturalism than the previous grade. So let's talk about these. One way not to even get a grade is to deny that there's any such thing as modality of the objective kind. So if you just say it's part of what we can know a priori that there's no such thing as real modality in the world, not even like the modality associated with laws of nature, then you don't get onto this grade scheme at all. All these grade schemes are kind of views about objective modality considered as a real phenomenon. Van Fraasenas's paper, The Only Necessity is Verbal Necessity, he's basically denying objective modality. He's not part of the scheme here. But grade 0 is a way of accepting the reality of objective modality, but not being naturalist about it. And this is a pretty common view. I mean, modal naturalism is controversial. It's not, I'd say, even a widespread view within metaphysics. I think modal naturalism of the kind I'll defend is much more common in philosophy of science than it is in metaphysics, perhaps for obvious reasons. But there's an awful lot of people, especially the more a prioristic metaphysicians out there, that think that science can tell us about modality, but it can only tell us about the nomological kind. It can tell us what the laws of nature are. Like, what else are we going to do to discover the laws of nature except science? But that tells us about nomological modality. It doesn't tell us at all about the background space of metaphysical possibilities that's kind of lurking in the background. And so people at this grade are realist about metaphysical modality. They believe there is such a thing as metaphysical modality, but they think that background space of possible worlds is completely immune to scientific evidence. I think Armstrong, Beeler, and Lowe all took this sort of view. Perhaps David Lewis too, but you can have a discussion about that. Grade 1 is the first way of being a naturalist about modality. And the idea here is that we can discover new possibilities, new metaphysical possibilities by doing science. We can rationally come to regard something as possible that without scientific evidence, we couldn't have rationally come to regard as possible. And kind of the theory of evolution is a potential example of this. One species changing to another was considered, I think, I'd claim to be metaphysically impossible prior to Darwin. It was one of the reasons why the evolution got so much pushback. Likewise, relativity, especially general relativity, that leads us to think that space-time is curved. That's something that was explicitly kind of announced to be metaphysically impossible by multiple influential metaphysicians from the past. So I think those are kind of relatively clear cases. Lewis says something about quantum mechanics that may or may not be an example of this. So here's the kind of thing I have in mind for grade 1. These are all things that, like, at least on one interpretation, were judged to be metaphysically impossible at one point in time, and we now come to believe, or at least some of us believe, are in fact metaphysically possible, even actual. So the platypus, I'm told, people insisted, biologists, naturalists in Europe insisted that these things must be fake when the first specimens were brought back, because it was just, metaphysically impossible for this sort of ingredient to be on that sort of creature. There's linked to the way that you can hardly see it here, but this is a kind of evolution of humans from apes image going on. As I understand Aristotelian biology, it's contrary to the nature of things for one species to change over time into another species. Atoms were considered the kind of thing that it was metaphysically impossible to split. That turned out not to be correct. Continental drift, arguably. The moon, on some views of what the moon was like, was sort of just not the kind of thing that you could possibly land on. Maybe the moon was a god and you can't land on a god. It's again, contrary to the nature of things that we should land on the moon, but there we are. Curved space-time, the example I've already mentioned. I think that's perhaps the clearest example of all. And top right is a diagram from the original experiments on free will by Libet. So these at least purport to illustrate cases where it's possible to predict an action understood as a free action of an agent in advance of that agent reporting that they have made the decision. So the agent, kind of when the agent report they make the decision, is that vertical line, but you can see that if you're tracking the brainwaves, you can see that the peak is starting to build before that report kind of comes in. So again, extremely controversial, that case. Maybe all of these cases are in some way or other controversial, but hopefully they kind of help you triangulate on the kind of thing I have in mind by a scientific discovery of metaphysical possibility. It's kind of rational change from regarding something as metaphysically impossible to regarding it as metaphysically possible in virtue of having done some science. So I think that's an interesting kind of naturalism. But it's generally about kind of expanding our horizons, kind of coming to recognize possibilities where we didn't recognize them before. It's another thing altogether to kind of reduce our view of the possibilities, the genuine possibilities, down in virtue of doing science. And one way of doing it, I don't think is necessarily a particularly interesting way of doing it, for reasons I'll explain, is what I'm calling grade 2. It's associated particularly with kind of post-Kripkean metaphysicians who take seriously what Kripke said about the necessity of constitution as applied to natural kinds, as applied to natural properties. The kind of thought is that if part of the nature of electric charge is to repel other similar electric charges, then anything that doesn't repel other like properties just can't be charge. It must be something else. Therefore, it's metaphysically necessary that like charges repel. But the reason why it's metaphysically necessary that like charges repel, for like this idea that Kripke floats and that's been taken up by these dispositional essentialists, like Shoemaker, Sawyer, Ellis and Bird, is really about kind of what counts as charge, or what is rightly called, what is rightly identified as the same property as charge. It's not, in a sense, that's a little hard to pin down, but I think is hopefully going to become clear enough. It's not a matter of restricting the qualitative possibilities, because even if charges can't attract, most philosophers at this level still think that there could be properties just like charge, but that behave differently. So that in some circumstances, call them schmarges, that's a word that's got used here, like schmarges do attract in some circumstances. So these are alien properties not found at our world, governed by alien laws. So grade 2 doesn't restrict, in some sense, the qualitative possibilities, doesn't restrict the kind of structure of the space of possibilities, only restricts the possibilities by restricting identities about the properties, which properties are the same as which other ones. So you can challenge that this is not really a substantial increase in level of naturalism on grade 1 and 0. All we're learning through science is kind of which properties are which, not what things really can, what kinds of things really can happen. So grade 3, I think, is a much more interesting kind of instance of the same general phenomenon of science helping us to rule out genuine metaphysical possibilities, but not ruling out possibilities just that are to do with the identity of properties. Rather, at grade 3, you're ruling out possibilities that are to do with the structure of what's possible. So there are some kinds of things, no matter what you call them, no matter which properties that you identify them as, that just can't happen. So on this view, there could just be no such thing as schmarge anywhere in the world, anywhere in any of the possible worlds. So nothing that is remotely charge-like could attract anything else that is remotely charge-like, no matter where you go in the space of possibilities. I think of this as kind of a serious kind of naturalism that is still reasonably widely held. I mean, many of these people would think of themselves as radicals of one kind or another. So an earlier version of myself argued for this on kind of general metaphysical grounds. Edgington argued for this on similarly general metaphysical grounds. And people like Leeds, French, Ladyman, and Ross argue on kind of grounds more from the philosophy of science for this sort of level of naturalism about modality. The idea is that there are certain kinds of things that we can, by doing science, rationally come to discover are just not possible, when a priori reflection would have led us to regard them as possible. And Graham Priest thinks a similar thing when he thinks that, for example, that quantum mechanics shows us that contradictions are real. We might not have thought that there were any contradictions. I think that should be grade 2. Set Priest aside. I think in some sense he is adjusting the structure of the possibilities, but maybe only in an expansionary way, maybe not in a contractionary way. So then to point us forwards towards a case that will come up in the second part of the talk, consider space-time, consider the possibilities for space-time. One might find out by doing science, I'll suggest, that it is just not after all possible for space-time to have more than a certain number of finite dimensions to it. And not just because anything space-time-like with more dimensions than that wouldn't properly be called space-time, but because nothing space-time-like can have more than 11 dimensions at all. So here are some images of the kind of things I had in mind at grade 3. So several of these examples, one way or another, come from quantum theory. The idea that if you have perfect destructive interference of the wave function, there are places where you just cannot find a particular particle, no matter, and it's not a matter of just law, on some interpretations of quantum mechanics at least, it's not a matter of just some contingent law ruling out that a particle appears there. It's part of the structure of possibility space, as revealed by quantum mechanics, that there just is nowhere, no possibility there where the particle appears in those places. Black holes, part of the structure of space-time, that matter that has crossed the event horizon of a black hole is not coming back out. Thermodynamics, you can't have a heat engine more efficient than the ideal Carnot cycle. That's an attempt at a perpetual motion machine. It doesn't work, obviously, but the idea that one can't have a perpetual motion machine, it might also be an example of this sort of restriction on structural possibility. And finally, relativity, just special relativity, never mind general, I think gives us some fairly clear examples. Matter can't cross from inside a light cone to outside a light cone. It can't accelerate past the speed of light, not because of some contingent law governing the motion of matter, but because of what it is for matter to move. Matter just can't do that sort of thing. And nothing matter-like can either. So all of these approaches require something, I think, controversial when it comes to the interpretation of each physical theory involved. So you have to interpret quantum mechanics as kind of illuminating the structure of the genuine possibilities, not as merely kind of a contingent law about how the particles move, for example. So these are more plausible on certain realist readings of quantum mechanics, like Everettian quantum mechanics, than they are on, say, Bohmian mechanics, where you do have a kind of background space where the particles do whatever you like, and you can think of the guidance equation as law-like, as a mere law of nature. So these things are going to be interpretation dependent when it comes to the physical theory involved. Likewise for special relativity. But I think in each case, and maybe particularly in the relativity case, the most natural interpretation of the relevant physics is one that has these theories restricting the structure of the possibilities. So my experience is that philosophers of science, especially philosophers of physics, are generally much more comfortable with this level of grade 3 naturalism than straight metaphysicians, just because they're more familiar with these sorts of interpretations of the relevant physics and take them more seriously. So grade 4 is where it kind of gets wild. Grade 4 is a version of naturalism that I think very few people in the world would sign up to. I'm one of them. Perhaps Ladyman and Ross, perhaps Graham Priest, perhaps Stephen French also endorse a view like this, where science isn't just telling us kind of which possibilities there are, either by adding new ones in to our background space metaphysical possibilities, or by kind of cutting some out from what we would have thought that space was like. But it's telling us about that space itself. It's telling us about the phenomenon of modality in its own right. And to do that, you obviously need some quite robust bridge principles between metaphysics and science, usually physics. And I have a book, a recent one, where I argue that we can get a theory of the nature of metaphysical modality out of many worlds quantum mechanics. So the basic theory is just that what possible worlds are worlds of the many worlds interpretation, Everett worlds, I call them. And we have indexical actuality, as in Lewisian modal realism. So it's a kind of modal realism. And the claim is that kind of once we take ourselves to have discovered that many worlds quantum theory is correct, if we do take that to be something that we've discovered, or we do at least think it's plausible, or we suppose that we've discovered that, then the best account of modality would be this quantum modal realist account. So you can see, if you're unconvinced by the many worlds approach, you can just think of this hypothetically. Suppose you became convinced of the many worlds approach. Would you be inclined to use the worlds of many worlds quantum mechanics to give you an account of metaphysical modality more broadly? Of course, you're not forced into that, but my claim in the book, and I kind of make an extended argument, is that it's an attractive account of modality for people that have independent reasons to believe in many worlds quantum theory. And so in that case, it is, I hope, fairly clear that some putative discovery of science that the many worlds approach is correct is giving us reason to adopt a particular theory of what metaphysical modality is, not just which metaphysical possibilities there are or aren't. And of course, that's going to have knock-on effects for which possibilities there are, but kind of which its knock-on effects go via this identification of worlds as quantum things. So yeah, that's the controversial view. I'm not going to defend it any further here. I think it's a kind of plausible account of modality, and its plausibility partly derives from all the other accounts of modality being so bad. But for the purposes of this talk, it's only serving to give an example of this sort of extreme naturalism that I think is, at least in principle, on the table. So here's all the grades again. To get a grade, you have to take seriously objective modality. If you do, you can have various views about the ways in which scientific evidence bears on objective modality, ranging from not at all to kind of bearing on what it even is. And there are plenty of grades in between. I think there are probably even subgrades you can distinguish, especially with respect, if you think there's something like kind of in this notion of qualitativeness I was talking about, you might want to distinguish first order properties and higher order properties, properties of properties, functional properties, that kind of thing. So there's definitely texture in the middle as well. But these, I think, are kind of some interesting grades that are worth pulling apart. So here's an application of those sorts of grades. And I'm going to be talking about kind of the higher end of those grades, grades 3 and 4, as they apply to the modal status of space and time. So if you start asking these questions, kind of what could space and time be like? Like, what are the limits of the possibilities for space and time? Could there have been more spatial dimensions than there are? How many? Could there have been infinitely many? If so, what kind of infinity could there have been of spatial dimensions? What about time? Could there have been no time at all? Could there have been multiple time dimensions? Does that make sense? Could both space and time have completely failed to exist? Are there worlds with no space and no time? And from a kind of purely metaphysical, a prioristic point of view, these questions look pretty hard to answer. I mean, people have tried with kind of subtraction arguments, you can take some away, or they've kind of used principles about conceivability. You know, we can try to imagine these sorts of worlds, and if we succeed, then we've got reason to think they're possible. But our grasp on these questions, I think, is generally pretty tenuous. And most philosophers, even metaphysicians working on space and time, typically don't have very strong views about these questions or very kind of well-developed reasons for the views they have. Just to give some historical cases, Newton thought that, at least kind of a natural reading of what he's doing in the General Scholium to Principia Mathematica is saying that space and time are kind of aspects of God's nature. So they follow necessarily from God's nature that space and time have the properties that they do. And since God's nature is necessary, the features of space and time are likewise necessary. So space and time kind of inherit their modal status from God. That's not to say that we can't use, so that we're not going to be at grade 4 because science is going to be telling us about God, presumably. I mean, maybe Newton would have thought that we were going to get to grade 4 because we need science to tell us about the relevant aspects of God's nature. But at least it seems to be that we are at grade 3 because he used his argument, his bucket argument, the idea that when you spin a bucket full of water suspended from a rope, the surface will go concave, took that to be a reason to believe in the reality of absolute space. And then absolute space is meant to flow from God's nature. So we are getting some sorts of insights into the non-contingent properties of space and time by doing science. So Newton is turning out to be reasonably naturalistic by my criterion, but he's also having a very restrictive view of the modal landscape with respect to space and time. It has to be this 3 space dimension plus 1 time dimension thing. No curvature, no singularities. There are complexities here, but it depends whether you're talking about Newton theory or Newtonian mechanics in some more general sense. But I'll set those aside for now. So moving on to Kant, disclaimer, I know less about Kant really than I do about Newton, but as I understand Kant, what he was saying was space and time are sort of projections of our own nature. They're projections of our experiencing, of our sensibility, of our constitution as experiencers. And so even though there would be no space and time if there weren't experiencers and their own having phenomenal worlds of their own, nonetheless, given the kind of creatures we are, the features of space and time are non-contingent. So kind of space for us and time for us are not contingent. And in fact, they can be a priori deduced, as he tries in the analogies of experience. And he's even trying to get kind of features of Newton's laws of motion out a priori from what he takes to be features ultimately of our own constitution. So for us, there's necessarily, like Newton, there's necessarily a 3 + 1 dimensional Euclidean space-time, no curvature, no singularities. And of course, that immediately invites the question, what about other creatures with other sensibilities? Could there have been creatures that have different kinds of experiencing natures, that experience things in different ways, and therefore order things in some kind of higher dimensional space and time? My Kantian friends tell me that Kant was explicitly agnostic about that sort of thing. He kind of considers that at one stage, apparently, and says, he just doesn't think we're in a position to know about that. Kind of the fact that we are kind of limited in to our own phenomenal worlds kind of prevents us from getting outside it enough to work out whether there could be other creatures with other types of experience that do experience the world in these other ways. But if he had to guess, my guess is going to be that he would have been skeptical. So these sorts of considerations are tied to particular views about space and time. For Newton, it's tied to God. For Kant, it's tied to our own form of experience. How do contemporary metaphysicians think about that? Because they don't have those sorts of premises about God driving contemporary metaphysics, nor do they have the same sorts of premises about ourselves, or at least not on the surface. So David Lewis considers this question. I'm going to be quoting in the next few slides from some recent correspondence, the volumes of correspondence of David Lewis that was published recently by BB and Fisher, that I think kind of illuminate some of this stuff in a quite helpful way. Sometimes Lewis would say things to his correspondents that he wouldn't kind of put down officially in papers for whatever reason. So I've had some long-standing questions about Lewis interpretation, which got answered in a very satisfying way by some of these correspondences. And here's an example. So when Lewis is asked about like these questions about the modal limits of space and time, could there be worlds with different space, different time? He says, I think there are worlds. He does think that. He thinks there are worlds that don't have anything like our sort of space and time. So higher dimensional worlds, worlds with more spatial dimensions, for example. But he makes this interesting distinction that I'm not inclined to follow, but I think is worth noting, between questions about what sorts of worlds there are and what deserves what name. This is the kind of distinction that I was trying to make between levels 2 and levels 3, but I think Lewis is thinking about it slightly differently from me. So he says there's partly a substantive question about what possibilities there are, and partly a verbal question about what we should properly call those things. So why does he think that there are worlds that have different space-time properties from ours? Well, he considers this in a different lesson, just different correspondence. He considers this sort of argument. He's got this principle of recombination that says if you can have kind of this sort of thing and you can have that sort of thing, then you can have those two things together. It's kind of how he drives his account of what worlds there are. And he considers applying that recombination principle to space-time. He says, you know, you could have this this Euclidean 4D world and that one. And so if you can have them both, you can have them together. But how do you glue one 4-dimensional world to another 4-dimensional world? Presumably, you need a new dimension to line them up along. You know, with just 2 worlds, it would be just a 2-pointed dimension, but maybe you could have like continuum many such worlds all joined up along that dimension to give you a 5D world. So he says, I believe in 5-dimensional spacetimes, but I don't think the recombination argument for them is good. And I'd really like to have heard more at that point. He doesn't say why he doesn't think the recombination argument is good, nor does he say why he believes them. But I take it to be something like a principle of conceivability, or alternatively, a principle of avoiding arbitrariness. So I think the thought would be, it would be kind of arbitrary if you could have 4D spacetime, but you couldn't have 5D spacetime. Like, what makes a difference between 4 and 5? They're just 2 finite integers. If you can have this finite integer, what would make you stop at the next one up? I think it's something like that that is motivating Lewis. And something like that comes across in an explicit principle suggested by Alan Hazen. Again, it's from the same correspondence, but this is a letter from Hazen to Lewis. And Van Fraassen said something similar, but I'm still kind of out in the search for kind of earlier versions of this principle, if anybody knows of anything that might be resembled it. Hazen says that, put aside mathematical standards, it's not clear exactly what that means. Every model, a coherent, comprehensive physical theory corresponds to a genuine possible world. So basically, we work out which worlds are possible by working out which physixes are coherent, which systems of physics make sense. So this passes off all of like the modal judgments onto the judgments about when a physical theory makes sense and is complete and comprehensive. And one immediate worry about that is whether it kind of ends up making all this turn on the definition of physics, whether some theory counts as a physical theory or not. Perhaps that can be finessed. I'm not going to dwell on that. But it certainly puts a lot of weight onto these notions of comprehensiveness, but even more so on this notion of coherence. So here is something like a priori rational coherence, as I read it, that is being used to determine what possibilities there are. So ultimately, I think this is a non-naturalist approach. It's what is a priori coherent. Physics is coming in, but only by being the kind of things that we're considering the coherence of a priori in order to explore the space of possible spacetimes. You excuse that phrase. So this is a pretty common approach in metaphysics, but it's also pretty common in philosophy of physics. Philosophers of physics kind of take themselves to be hard-nosed anti-metaphysicians, a lot of them, but nonetheless, they fall back on something like this sort of conceivability inference when they're judging what possible spacetimes there are, And usually it's a matter of, well, what else can we do? Kind of hard to see what else we can do. I've been trying to suggest an alternative. So you might see, it might seem that like you can kind of build a coherent theory. If you can build a coherent theory with 3+1 spatial dimensions, you can build a coherent theory with 4+1 or so on. And if you can switch from Euclidean space to Hilbert space, then why not countably infinite spatial dimensions? So what might actually stop a theory of space-time being coherent? Maybe logical inconsistency, perhaps not even that. Some people don't think causal loops would lead to some kind of incoherence. Others would disagree. But it doesn't look like there's going to be a lot of considerations that are going to rule out space-time as possible. So we're going to end up with a very, very broad and open conception of what space-time could be like from this sort of approach. So in what remains of this talk, I'm going to talk about a different approach, which turns to theories of quantum gravity, particularly to string theory of a particular type. And it says and asks what those sorts of theories say about space-time, and then argues that we should maybe take seriously those theories as a guide to the full range of possible space-times. So we don't need to look outside physics to conceive of actual physics. Instead, we don't need to look to kind of conceivability or conceivable physics. We can make actual physics do the work when it comes to mapping out the space of possible spacetimes. So more generally, in these sorts of emergent spacetimes pictures, spacetime is not spacetime of our kind, this 3+1 dimensional spacetime that we live in. That doesn't turn out to be fundamental. There's some more fundamental structure, which is not 3+1 dimensional, which is responsible for the effective 3+1 dimensionality of spacetime as we experience it. And different theories disagree on what that background structure is like. In string theory, it's more resemble background spacetime, or the background space more resembles our ordinary spacetime than in loop quantum gravity, where there's something that's kind of doesn't look spacetimely at all that is at the fundamental level. But I'm going to focus on string theory, in particular, kind of 11-dimensional M theory, as I understand it, which is not particularly deeply, but hopefully enough to kind of make the example play out for the purpose of this talk. So the way I'm understanding this sort of M theory, it's a quantum theory of spacetime, and it says that effective spacetime can take different forms depending on how a particular quantum dynamical process, compactification, plays out. So we have a background spacetime with 11 dimensions, one of which is identified as a time-like dimension. And that is that spacetime is itself a dynamical object in the theory, and it can effectively decay into different effective spacetimes. So the way I'm thinking about this is a so-called string landscape. You can think of it as a massive massive landscape, a massive membrane with bumps in it, with minima, like particular places where the actual world can end up. So again, in this kind of naive picture, I'm thinking of our world as kind of doing some kind of random walk across this this membrane and eventually falling into one of the holes. And once it falls in, it tends to stay there because probability of getting out is really very small. C.S. Lewis has the first book of the Narnia trilogy has this fancy of the wood between the worlds, which is like a wood that you can wander around in, and it has lots of pools in, and you fall in one of the pools and you end up in a different universe with very different stuff going on in it. And that's kind of roughly, I think, a useful way to think about this, the string landscape view. So when you kind of end up, the actual world ends up in one of these minima, what's happened is some of those background spatial dimensions become tightly rolled up, compactified, and they become effectively irrelevant to the resulting physics. Resulting physics plays out in whichever dimensions haven't got compactified in that way. And so there's different ways in which that procedure can happen. A lot of them. sometimes a number of 10 to the 500 gets thrown around, which is a very, very large number. There's a kind of combinatorial explosion of the different ways in which this procedure can occur. And these different compactifications, some of them are four-dimensional like ours, and others aren't. It's not even known like what proportion of them are four-dimensional, but some of them are going to be and some of them aren't. We know very little about this landscape. We don't know how big it is. We don't even really know how anything about the statistics of it. But because the mathematics is extremely difficult and intractable. But from a kind of string theory point of view, what kind of the goal is, roughly, is to find at least one minimum of the landscape which looks like ours. And you can say, well, that's fine, because that's where we've ended up. Never mind how. So the theory is empirically adequate now, because we've got at least one kind of domain of the theory that corresponds to what we actually observe. So kind of forget about the others. Maybe you give some kind of anthropic explanation of why we see what we do in terms of only life-supporting structures being possible in a few of them, or maybe not. Maybe you're just happy to say, well, my theory predicts that it's at least possible that we see what we see. That's still better than nothing. So anyway, the point is there's this big landscape of possibilities for the string theory vacuum to compactify to give different effective spacetimes, of which ours is identified as just one of the possibilities. So how should we think about those possibilities? On what I think is kind of the orthodox view, or like the application of the orthodox view, a 4D spacetime like ours could be emergent from string theory. I mean, if string theory is correct, it is. But still, says the orthodox metaphysician, there is a metaphysical possibility where it's not emergent, where that spacetime like ours is just a fundamental thing that's just there, without anything that it's emerged from. So exactly the same spacetime, for all effective purposes, is there as an emergent thing, and there's a separate possibility where that spacetime is there as a fundamental thing. The necessitarian view denies that second kind of thing. It says that all there are the emergent spacetimes from the correct theory of quantum gravity. There are no other possible spacetimes at all. This would be at least level 3, this necessitarian view. So here's 3 quick arguments that I'm going to kind of display more than like go into in detail for why you might prefer the necessitarian view to the hybrid view, for why you might think that all of the possibilities of space-time are found in the actual theory of quantum gravity, rather than space-time also extending into these other metaphysical possibilities where quantum gravity is false. So many of what we think are kind of intuitive possibilities for space-time, or at least some of them, are recovered. Different dimensionalities of space are recovered. Space-time could have been 4 or 5 or 6 dimensional. But it couldn't have been higher dimensional without limit. And there's a kind of answer to the arbitrariness challenge that's to be found in the mathematics of the theory. The mathematics of the theory tells you why there couldn't have been higher dimensions than 11. And if we have the hybrid view, so that like a 5-dimensional spacetime or a 4-dimensional spacetime like ours is possible as emergent from string theory, but also possible as just a fundamental thing on its own in a possible world by itself, then we have these sorts of possibilities effectively redundantly. We have a spacetime like that possible twice over. And you might think that that's unparsimonious in some sense, so we should reject this hybrid view because it's ended up with too much redundancy in the space of possible spacetimes. That's really going to be something you're only going to think if you take a sort of possible worlds first view, where kind of more worlds is a more complex theory of modality. If you take a kind of necessity first view, where like fewer worlds is more necessary principles, and a more complex theory of modality has more necessary principles in it, you won't think this is unparsimonious. But that's just an aside, really. This is one sort of argument based on redundancy of possibilities that I think is worth thinking about. Another argument is much more epistemic. It says that if the kind of hybrid view is right, then we're in a position where we can't know a lot about the space of possible spacetimes. We can't, it's pretty hard. They're pretty intractable questions, pretty imponderable, about what sorts of possible spacetimes there are. But if we adopt the necessitarian view and say all the possible spacetimes come out of the actual theory of quantum gravity, then we can do physics and get some answers. I mean, maybe it's pretty hard to do the relevant physics, maybe the maths is hard, but that's like a mathematical problem, a physical problem. It's not a conceptual or philosophical problem. So we're on better epistemic grounds if we accept the necessitarian view than the hybrid view. We're in a better position to really kind of make confident judgments about what possible spacetimes there are. And the last argument is a kind of Kripke style argument from the necessity of constitution, as came up earlier. It says, if spacetime is in fact emergent from quantum gravity, then it's part of the constitution of spacetime as we encounter it to be emergent as opposed to fundamental, part of what spacetime is. And constitutive facts, says Kripke, are non-contingent characteristically. So we get a direct route to the necessitarian view. I discussed this paper, this argument at length in a paper called, I can't remember what it's called. It's in the reference list. Should remember. Explanation in and of time, that's what it's called. So this is the Kripke style argument, like other Kripke style arguments, can be resisted via functionalist approaches. So if you want to say spacetime is a functional term, then necessity of constitution only applies to the kind of realizers, not to the functional roles. And so if you follow somebody like Eleanor Knox and say we should think of spacetime as this functional concept in physics, as a kind of a role rather than a realizer, then we can resist this sort of argument in the same way that generally functionalism can resist these sorts of necessity of constitution arguments. So those are the three arguments. I think they're all interesting. They're all quite different. They tend to appeal to different sorts of constituencies. But I think they're really there to kind of prompt discussion. So that's it. Here's the basic conclusions. I think we should be trying to take account of science, especially physics, when we're doing fundamental metaphysics. When we try and do that about modality, the metaphysics of modality, we can have this kind of nuanced view that has degrees of naturalism about modality. And then when we apply that to space-time, we get at least the prospect of a naturalistic view of space-time that says, whichever is the true theory of quantum gravity, thinking about that is the way to find out the limits of possibility for space-time. And then I gave these three arguments for a necessitarian view that puts all the space-time contingency there is into physical contingency of where we end up within the space of quantum gravity possibilities. Thanks.
Stop the recording.